Okay, so this is your crash course on quantitative methods in one lecture. I'm going to try to give you all of the most important things in 20 or 30 minutes, or maybe even less. We'll see. Okay, so let's get started. So the biggest thing to remember in quantitative methods is that we have to start a bit at the beginning and do a bit of a review. And so let's just start with what a theory is. And I like to use the definition, an integrated set of explanations in the political and social world. And for quantitative scholars, we often consider these relationships between certain concepts. We want to test these theories, and so to test these specific theories, these explanations, we're going to look at figuring out whether one thing causes another thing. So that one thing is the independent variable, which then causes the dependent variable, or at least that's what we'd like to show. Now, the easy way to remember that is that the dependent variable, it depends on the independent variable to happen. So here's an example. There's a theory that higher wealth is going to lead to a better quality of democracy. We have this idea, the Lipset hypothesis, that if people have more wealth, if they're more empowered with their own finances, if they're more educated, all of this modernization thesis stuff happens, you're going to have people who are ready to participate in a better quality of democracy and are going to demand better quality representation. Okay, so what we would say here is that the quality of democracy, or better quality of democracy, is going to depend on higher wealth, say, in a country. Here's another example. So this is actually stuff that I am working on right now. The greater total political donations to a candidate means that you're going to be more likely to have a higher percentage of the vote share. And so in this case, we would say, well, the vote share is going to depend on the money that you're getting. So essentially, hypotheses then are predictions about these relationships between two concepts. And sometimes I like to use this prompt to write a hypothesis. So I predict that, so use any variation of this independent variable, higher, lower, better, weaker, it is or it isn't, of this independent variable is going to lead to, again, variation, higher, lower, better, weaker, is or isn't, of the dependent variable. So I predict that higher wealth is going to lead to a better quality of democracy. Or I predict that a greater amount of donations are going to lead to a higher percentage of the vote share in an election. Okay. And so there are a few things about a hypothesis that need to be there just to get these foundations correct. So first, it needs to be a relationship between two variables. So check, we got that. It has to be a comparison between values of these independent variables. It can be a variable on a scale. It can also be a binary variable, so just two options, it is or it isn't. You voted or you didn't. So it can also be a binary variable if it's not on a particular scale. There's going to be some sort of prediction about the direction of the relationship. So more wealth, better democracy. More wealth, win an election. And that it is something that you can empirically test. And we're going to get to that. So your first little try it out will be to write a hypothesis for each of the following relationships. It can go a variety of different ways, and then evaluate them according to the principles. So there's two different prompts here that you can try out. Maybe pause the video, see how you do, and then we'll come back and evaluate them. Maybe I'll use this one here. So the relationship between bike lanes and neighborhood pollution. So maybe I have this theory that when people ride bikes instead of driving cars, there's going to be less pollution in the air. The air quality will be nicer or whatever. Okay, so then my theory would be that having bike lanes, or as opposed to not having bike lanes, is going to lead to lower neighborhood pollution. So is it a relationship? Yeah, it's a relationship between bike lanes and pollution in that neighborhood. Is it a comparison in the independent variable? Well, in this case, it's you have bike lanes or you don't have bike lanes. I could also say the number of bike lanes, or I could say the percentage of streets with bike lanes. So there's a variety of different ways that could be measured, which, as you can see, we're going to get to in a moment. Is there a direction? Yeah, because I think that it's going to be that more bike lanes lead to less pollution because I have these theories that I've done through a literature review about biking and carbon dioxide emissions or whatever. And then is it empirically testable? Well, I guess like if it'd be hard to, but you could strike a deal with the city and say, okay, this neighborhood I'm going to put bike lanes in, this neighborhood I'm not, and then we're going to compare the two. Now, is that overly simplistic? Obviously. And somebody who studies kind of environment and climate is probably going to say, you realize that, this isn't how it works with bike lanes and neighborhood pollution, but I think you can kind of get the gist of what we're looking at in a hypothesis, especially in this quantitative field. All right. So let's say we are interested in this hypothesis. Higher levels of education are going to lead to greater political participation. So if we look at, there's this relationship between education and political participation. We're comparing independent variables, so higher versus lower levels of education. There's a direction. We say higher levels, greater participation, and it's something we can test, and we'll talk about that in a second. But both of these variables are currently just concepts, and concepts are generally more abstract ideas, and it takes a lot of theorizing to kind of understand and nail down what do I mean by this concept. So let's define that. So what is education? What is political participation? And generally, what we'd use to define these concepts is the previous research. So what has been talked about what is education, what is political participation. So not just the dictionary. All right, so here's where we would brainstorm. Okay, well, what does education mean? And I would base this on other literature, but let's just say we were brainstorming today. Someone might say, well, maybe it's formal studies or formal training. Someone else might say, well, it's about competence, so having a certain competence to do something or not. Same with political participation. Maybe it's having efficacy to make a difference within the social order, or whatever it happens to be. And note that people will be debating how to define these concepts for their entire career. But we really need to nail down what is that concept, because now we're going to move from the concept to an actual measure. All right, so there's a variety of different things we need to think about when we are measuring. So first we need to consider what is our unit of analysis. And so this refers to the cases or the subjects that we will be studying. So for this particular study, we could think of a few different research projects. We could compare countries' levels of education and political participation. We could look at quality of education in different schools and how much their students participate. Or we could look at the student level. So we could consider at the individual level their personal educational attainment and whether they participate or not. And so in general, for today at least, we're going to say that our cases are going to need to be the same unit of analysis. All right. So let's say we wanted to measure education at an individual level. What would we say? Well, maybe we could ask in a survey, we could ask people, okay, what's the highest level of education you've received? And so that would be very much stemming from a concept of education that rests on formal studies. Where it's something that we were trying to go based on this concept of more of a competence-based concept of education. Maybe what we would do is some sort of a test to see their competence in a certain field. But we would be doing this at the individual level. Political participation at the individual level, well, there's a variety of different individual actions that might express this political participation or this efficacy that someone might have. Maybe it's going out to vote. Maybe it's being able to give political donations. Maybe it is going to a protest or signing a petition. But it would be on the individual level, what actions are they taking, for example. Let's look now at the school level, education at school level. Maybe we could use, if we wanted it to be based on kind of formal studies, or maybe what percentage of the kids at that school get into college, or it could be what are their test scores. Political participation, it could be what percentage of the kids at that school who are eligible to vote actually vote. That would be useful, say, at a university setting, or how many students vote in their student government elections, that kind of thing. At the country level, education, you could look at maybe PISA scores, so specific scores to look at literacy levels in the country, or the proliferation of post-secondary educational institutions. Political participation, that could be voter turnout in the country. It could be the number of times they've had democratic alternation. So there's a variety of different, well, I guess that wouldn't really be participation, that would be more like quality of democracy. So maybe something like, maybe you do a survey and you find out how on average, this population, how do they feel about how how much effect they can have on their government. Maybe there's some sort of an opinion question you could ask, or attitudinal question. Anyway, but all that to say, there's different ways of measuring things based on what unit of analysis you're looking at. Another dimension of measurement is the type of measurement we're doing. So there's generally 3 options. There are more, but we're doing a crash course, so it's just going to be 3 today. Binary variables, so that's the 2 options, yes, no, on or off. Went to high school, didn't go to high school, for example. Voted, didn't vote. Categorical, so that could be made up of categories. It could be a Likert scale, like how much do you agree that you have a say in what your government does? I strongly agree that I have a say. I strongly disagree that I have a say. Or it could be different categories of education. Do you have post-secondary education, high school education, or elementary education? And then discrete or continuous variables, which are on some sort of scale. So things like age, height, income, your test score on a particular test to measure competency. And so what we would say, if we'd actually filled this out, this would be the point where we could go through and say which are binary, which are categorical, which are more discrete or continuous. Here I just used the word linear. I should write discrete or continuous there. But you can go through now and do that for whatever concept measures you came up with here. But we gave some good examples already, so you should get the drift. So now what we can do is we can further refine our hypothesis by taking into account our measure. So we had this hypothesis that higher levels of education will lead to greater political participation. So let's try to be very specific now using our measures. So we might say that an individual having post-secondary education, as opposed to not, so it's a binary variable, will lead to them being more likely to vote. Okay, so that's at the individual level. I can measure whether they have post-secondary education or not, and I can measure whether they voted or not. Maybe at a country's literacy level, a higher literacy level in a country will lead to greater average feeling of political efficacy, or whatever. So there's a variety of different ways. This is obviously where research starts to get interesting. Okay, how am I going to measure? At what level am I going to be measuring? Okay, so now we want to test our hypothesis, and there's various forms of hypothesis testing that we can use. And I might be saying something that will get some debate, but I would probably say that in the quantitative methods, the gold standard of testing the hypothesis would be an experimental method. Okay, so an experiment generally has the same features. So there's going to be an experimental group, which is a randomly selected group of individuals, which is subjected to a treatment, and a control group, which is not subjected to that treatment. So it's just like, I don't know, when you were a kid where you took a plant and you took 2 plants and you put 1 plant in the closet and it didn't get sun, and then you put 1 plant by the window, and the only thing that differed from these 2 plants was the fact that one had sun, one didn't, so we could say that sunlight makes the plant grow. Okay, so you kind of get the gist of it. Here's an example that we do in a classroom setting in the natural world. We might predict that running on the spot for a minute will increase my heart rate. Okay, so you test it. You get half the students to run on the spot for a minute, you get half the students to just sit. And then you take the 2 heart rates, you take the average, and we find that the people who did run on the spot for a minute had way higher heart rates. Okay, makes sense. Now you might be saying, yeah, but how do you do this in the social world? You can't experiment on people in the social world, but actually you can. So I did an experiment about knowledge about single transferable vote, which is an electoral system. Does it make people more likely to be in favor of it? So I thought that, yeah, if you know more about it, you're going to be more willing to reject the status quo of the single member plurality system we have. And therefore you're going to be more likely to say, yeah, like I know about it now, it doesn't seem scary, I'm gonna be willing to try it out. And so what I did is I gave a bit of a simpler design, but just to kind of boil it down, you gave half the students an article about single transferable vote, half the students got an article about something completely different, about, just a control text that was about, printers or something. And then you saw, okay, did the group that got the text about electoral reform end up supporting it more? And we find out that it does. There's also ways that you can measure outcome before and after the treatment, if it's applied for both groups. There's also cases where the lapse of time just in general is going to produce an outcome. So you might do a pre and post test experiment too, but I think you can probably get from this is the general idea behind an experiment. And so in a lot of the social world though, we can't really do these sorts of experiments. It would be very unethical to randomly assign children to go to school or not, and then see when they turned 18 if they got into university or not. Probably can't do that. So what we try to do then is we try to approximate that experimental methodology where the independent and dependent variables have already been observed in the world. And usually these observations are just a sample or a subset of observation from the full population. Because obviously I'm not going to ask every single Canadian what they think, because that would be really costly. And there's no good reason to, because I've got inferential statistics. Okay. So inferential statistics is essentially just asking this question: can my sample that I took of 100 randomly selected Canadians make any conclusions about the whole population? Now, you could take an entire course just on this, and if we had more time, we could get into that. But essentially, this is just looking at a few different ways that we might, based on what our variables look like. But just be aware it exists. Get into the weeds if you need to later on. Okay. But let's talk a little bit about correlations, because we actually talk about it all the time in popular media and such. Something is correlated, something's related to each other. So let's just do a brief look at correlations. So a correlation actually will give you a number between -1 and 1. The sign, so plus or minus, tells us whether that is a positive correlation, so things are going up together, or a negative correlation. One thing is going up while the other thing goes down. The number, or the magnitude, tells us how strong that correlation is. So are the dots really close to the line, or are they all kind of spread out? If you were actually to probably do any of this for a research project, we need to go through that a little bit more in more detail, but I think people can generally get the idea of a scatter plot. And, are the dots tending to go this way, or are they tending to go that way? So here's an example, just so you can see and understand. So in my research on electoral management, I might be interested in testing whether a country's wealth has an impact on the quality of elections. I predict that a higher wealth in a country is going to lead to better quality elections. It's my hypothesis. It's based on theories about resources and then an individual's desire to participate and their willingness to really demand that they have free and fair elections. See Mr. Lipset and many other theorists. So I decide I'm going to measure wealth according to gross domestic product, per capita purchasing power parity at the country level, and election qualities according to a perceptions of electoral integrity index. So we could create a scatter plot where we put all of the indicators on a graph. So this is their GDP, and this is their perceptions of electoral integrity index. So as their wealth goes up, does their electoral integrity go up? And so we note that there appears to kind of be a positive correlation. I just drew this red line in here. It's not actually part of the scatter plot. But you can see generally as wealth goes up, the quality of elections go up. And if I do my statistical fancy stats, I find that there's a 0.49 correlation because it's positive. Both are going up at the same time. And there's some magnitude of how close the dots are to the line, but it's not like a magnitude of 1 would be the dots are a line. So so that would be just really quickly how I might do a correlation. But you're thinking, yeah, well, maybe it happens that there's something about all of these rich countries, maybe they have more experience with democracy, or maybe there's something else going on here. And yeah, you're right. The world is really complex, and sometimes we can think correlation means causation when it doesn't. For example, here's some examples of places where things move together. They seem to be moving together, but there's probably actually no relationship because the world was just messy, right? So here we see U.S. spending on space, science, and technology, and suicides. One of my students actually suggested once that it was because people were becoming despondent based on all of the new technology in the world, which is not a bad idea, maybe. But again, sometimes things just move together. Modernization happens and things happen. Here we see eBay total gross merchandise volume and total Black Friday revenue. Well, what's going on here? Well, probably eBay is selling things on Black Friday. So first of all, that is contributing. And then also, like, you can just see the rise of internet commerce might be driving both of those. And so we can't necessarily say it's all just eBay making everything go up. And then here, this one's, it's weird because the x-axis here is just by generation, and that's just weird to begin with. But people who won't try sushi and people who don't approve of gay marriage. So there's probably some deeper characteristics of these generations at play. Openness to new things, maybe, or some sort of deeper ways of thinking, maybe, that are impacting these things. Anyway, or maybe there's even a generational effect, But point being, not great. So essentially, there's tons of graphs like this that you can see on the internet. The best one I saw was like a cat lying in a crack on a pavement, and it's like correlation does not equal causation, because obviously the cat did not cause the crack on the pavement to fall, but you never know, really. Anyway, okay, so sometimes we might find that things are related, but it is actually just a spurious relationship. So this means that another variable is influencing both the independent and dependent variable, and we call this a confounding variable. So this confounding variable influences both of these, which means they are connected, but not in the way that you think they are. So let's think of an example for confounding variables for post-secondary education and higher voter turnout. So let's look at maybe the individual level. So an individual who has post-secondary education is more likely to turn out. Well, maybe it's actually a matter of the parent's income. Parent can afford to send them to university. Parent also is likely to have been voting, because we know that income is related to voting, and maybe they took their kids to the polls more often, and therefore they were socialized into voting. Maybe people who live in a rural or urban area have more, or maybe rural area would have less access to both post-secondary education and a longer drive to the polls, and so that's why they would be less likely to vote. Maybe it's an age or a generational thing that, we surveyed a bunch of people who hadn't finished post-secondary education, so but they were also young, so they hadn't, they're less likely to vote. So there's all these sorts of other factors that might make something seem related when really it's the other thing that's driving it, and that's what we call a confounding variable. So what do we do there is that's usually when we would have to control for that, and that's where we're going to move into a regression analysis, which you're going to see in a subsequent video.